So let's take a look at some examples. Let's take a look at the first example, and I'm going to show you how to determine whether or not it is a function based on the picture. So let's take a look. I'm just going to pull this up. Okay, so let's take a look at example 1A. So if you had to recopy that down, you can just pause, go back, rewind, pause, and hopefully you'll be able to take it there. All right, let's take a look at example 1. Example 1 says negative 2, 2, so these are a whole bunch of relations, right? They are pairing exactly one input with exactly one output. So the idea we're trying to do is to determine, is this a function or not? So when you're given an ordered pair, there is a shortcut I'm going to show you in a minute, but I want to show you how you can always combine the two and try to determine whether or not the relation that is shown is a function. So here we have our x values and our y values. So we're going to take all of our x's, this guy, this guy, this guy, this guy, this guy. And we're going to take all of those x values and we're going to put them into this box right here for our x's. So we have negative 2, negative 1, 0, 1, and 2. And if you notice, they're not repeating anyway, but if they repeated, I would just list them once. So let's take a look now at our y values. Our y values are 2, 2, 2, 0, and 0. So notice they repeat, so I'm only going to write it one time in the box. I'm going to write the number 2, and I'm going to write the number 0. Even though they repeat, I'm only going to write them one time. So now we're going to show, are these is this relation a function? So my negative 2 gets mapped to my 2, so I'm going to draw an arrow between them. My negative 1 goes to 2, so I'm going to draw an arrow between them. My 0 goes to 2, so I'm going to draw an arrow between them. 1 goes to 0, so I'm going to draw an arrow there. And 2 goes to 0, so I'm going to draw an arrow there. Now we're looking to make sure that every single one of these inputs has only one output. So if I look, any line going from negative 2 over to the y, there's only one line and it's going to 2. So the input negative 2 has only one output, 2. Negative 1 is paired to 2, so it only has one output, 2. 0, output, 2. 1, output, 0. 2, output, 0. So each input has only one output. Therefore, this is a function. So go ahead and write that on the side. This is a function. If we take a look at the second example here, and I'm going to just move this down a little, and we're going to draw the same type of a mapping. So we have our x and our y. And we're going to put in our x values, right? 4, 8, 6, 4, and 5. So I'm going to have 4, 5, 6, and 8. So notice they do repeat a little bit, and I just wrote it one time. Now I'm going to take my y values, 0, 2, 3, 4, and 7. And we're going to draw our lines to show the relationship between the two. So our 4 gets mapped to 0, based on that. 8 gets mapped to 7. 6 gets mapped to 4. 4 gets mapped to 3. And 5 gets mapped to 2. So if you notice, 8 to 7, 6 to 4, 5 to 2, those are all those inputs have exactly one output. But this guy, number 4, has two outputs. 4 has an output of 0 and an output of 3. See, basically our inputs represent our x's and our outputs represent our y's, right? So that's the idea here. So this is this a function or it's not a function? Well, because this 4 has two outputs and not just one output, this is not a function.